Okay, so we're going to start our chapter with quadratics today. We're going to do transformations of quadratic functions, and we're going to use the graphing calculator for today's lesson, and then everything else is going to be the scientific calculator, okay? This is going to be really simple. We're going to be able to get the tables from the calculator, and you just have to think about the transformations, which the transformations we did with absolute value, if you remember that from chapter 1, they're pretty much the same because absolute value and quadratic are very similar to each other, okay? So a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a cannot equal 0. If a is equal to 0, then you lose your x squared term, and that is your quadratic part, so you need that, okay? The U-shaped graph of a quadratic function is a parabola. You should already be familiar with this because you did cover this in Algebra 1. The vertex of a parabola is the highest or lowest point of the graph, and it is in the middle. Just like the vertex of absolute value was in the middle, that's what this is going to be. The absolute value was a V, parabola is a U. Okay, everything else is pretty much the same. Your axis of symmetry is the vertical line that passes through the vertex and cuts the graph in half. Now, because it's a vertical line, what should my equation start with? X equals. So your axis of symmetry is always going to be x equals a number. Okay, now we're going to talk about the parent function first. So the parent function of a quadratic is y equals x squared or f of x equals x squared. F of x and y are interchangeable. Remember, this is just function notation, and this is just y. Okay? So what we're going to do is we're going to graph that in our calculator first. So you should be in Scratchpad. We don't do anything in documents. Okay? So turn it on, and if you're not, like if you're at the home button, or if that's what your screen looks like, that calculator button to the left middle is what's going to get you to the Scratchpad. Okay? Now, if you hit that button one more time, that calculator button gets you to the graph, okay? And so we're going to type, so that f1 of x is just your y1, basically, okay? So you're just going to type your x squared, enter, and that's the parent function for your quadratic, okay? Now, to get the table, we're going to do Control T, T for table. So Control is your, should be gray button, and then the letter T. Okay, remember it's not like a computer. You don't have to hold control down. You can just press control once and then T. Okay, that should split screen, your graph on the left and your table on the right. Right? Okay, where is my vertex for this graph? 0, 0. So remember, your vertex goes in the middle of your table. Alright, so we're going to put that our vertex is 0, 0, but when we build our table, that goes in the middle. It's the middle of your graph, so it goes in the middle of your table. Alright, and then we do those 2 points above and 2 points below. So my 2 points above, negative 1, 1, and negative 2, 4. And then 1, 1, and positive 2, 4. Okay, we all good graphing that and getting the table? Alright, so we're going to plot those points and draw our parabola. extend the both sides at least a little bit of ways. Don't make it super short. Do it a little bit of ways. And remember to draw your arrows because it is a continuous function. Okay, once you do that, we're going to talk about our axis of symmetry. I said that's the vertical line that passes through the vertex. So if I were to draw a vertical line passing through the vertex, your axis of symmetry, we actually draw a dashed line. It's like a line of symmetry. If you remember, like, I want to say elementary school, but I don't really know. When you would do symmetric parts, y'all would cut shapes out and fold them, see if they're symmetric. It's like your line of symmetry. Okay? So my equation for that axis of symmetry should be what? X equals 0. So your axis of symmetry is always going to be the x value of your vertex. Whether it's your parent function or a transformation, it will always be the x value of your vertex. Okay, now I'm going to skip domain and range till the end. We're going to look, is my vertex a maximum or a minimum? Minimum. It's my lowest point of the graph. So it's a minimum at y equals what? 0. Okay. Now my transformations, this is my parent function. You're not going to have transformations for a parent function. Anything other than just x squared will be a transformation though. Okay? But for now, there's going to be none because this is your parent. Now your domain, if you remember from Algebra 1, your domain is a set of all possible x values. Okay? So your x-axis goes left to right. That's what we're going to look at. We're going to go from our left to our right side of this graph. So if I look at my furthest left point, which is really here, do I have an end point or does it go on forever? It goes on forever because I have arrows. What about my right side? It goes on forever. Because of the fact that this is a continuous function, I have arrows on both ends, my domain is always going to be all real numbers, okay? We're going to write, I'm going to let you decide either interval or set builder, if you remember that from chapter 1. But I'm going to write it both ways for whoever decides what, okay? So, do you remember how to write all real numbers in interval notation? What would we do? Negative infinity to positive infinity, okay? As set builder, remember you had your little squigglies with your x and your bar, and what would we put for all real numbers? The x-e-r. I have to write that really small, sorry. Okay, so your domain, because you have arrows on both ends, will not change. If you don't get a single thing right from these problems, you should at least get your domain right. Okay, because that's going to be the same every single problem. Now your range depends on where your vertex is and what direction your graph is opening. Okay, here your range is a set of all possible y values. If I'm going from smaller to larger, that means I'm going from the bottom of my graph all the way to the top of my graph. Okay? So the bottom of my graph, we said our vertex was a minimum, so that's where I start. I'm starting at 0 and I'm going forever upwards. Okay, so my range is going to be what? 0 to infinity. And remember, you can have a bracket on that 0, because what does that bracket tell me? It's equal. I have a point at 0, so it's equal. Now, if I was doing set builder, I would have a y with a bar because my variable is y. And what would my inequality be? Y is what? Greater than or equal to 0. Okay, that range will always be the y value of your vertex. Okay? Alright, now, vertex form. Vertex form is just like vertex form for absolute value, except you have parentheses squared instead of absolute value bars. Okay? So your vertex is still going to be at HK, if y'all remember that. What was special about our H? It's the opposite sign. Remember, I always said x is a liar. So your h, the x value of your vertex, is the opposite sign of what your equation states. Your k is as is. So if it's a minus 50, then you got negative 50 for your y value. If it's a plus 100, then it's a 100 for your y value. Okay? Your vertex is still going to go in the center of your chart, and we're not going to do decimals or fractions in the chart unless it happens to be your vertex. Okay? Your axis of symmetry, we said is x equals, and I said it's the x value of your vertex. If the x value is h, right now our axis of symmetry is x equals h. But again, all you have to know is it's x equals the x value of your vertex. Okay, so our a value, the number in front of parentheses, if you remember, that told us if it was a stretch or a shrink. Y'all remember that? Okay, so we're going to revisit that, but for now, we're going to look if a is greater than 0, meaning if it's positive, your parabola is going to open up. Okay, and it's going to look like what we just drew with your vertex right there. But if the value is less than 0, meaning it's negative, then your parabola is going to open down, and that's going to give us a reflection. So the moment you see a negative, you have a reflection. Remember that? So you're going to have a minimum when the graph opens up, and you're going to have a maximum when the graph opens down. Now, I'm going to do, before y'all flip, I'm going to refresh your memories on those transformations like I did when we had absolute value. Okay, so remember that this a, if a is greater than 1, what do I have? A vertical stretch. Okay, if a is between 0 and 1, so a fraction or decimal less than 1, that's going to be a vertical shrink or compression. Bless you. Okay, what does this h tell me? It's happening to my x, so left or right. Okay, but remember x is a liar, so if your equation has a plus, you're really going left. If your equation has a minus, you're really going right. Y'all remember this? Okay. Then the k tells me up or down. If it's a positive, it goes up. If it's a negative, it goes down. And then your negative, if you have a negative, it tells you reflection. Y'all good with that? Okay. Now, this first section, we're not graphing. I give you the equations, and we are going to put it in our calculator and copy down the table. But before you type it in your calculator, I want you to get in the habit of identifying the vertex before you type it. Because the 3.2 lesson that I was about to teach y'all, you have to identify the vertex without a calculator. Okay? So if you compare vertex form to what I give you, okay, this is my vertex form. If I'm looking at example 1, do I have anything in parentheses attached to my x? No. So that means my x value of my vertex would be 0. Do I have anything added or subtracted behind my x squared term? No. So that's also 0. So 0, 0 is still going to be my vertex for this particular example. Okay? Then I'm going to go to my calculator. I still have my graph and my table up. The easiest and less amount of buttons you could press is just doc B it. So doc B. How we clear it, just clear it every time and start back from scratch. So doc and then letter B. And then hit that calculator button one more time. Get you back to your graph. So now I'm going to do a negative. Remember to get a fraction. Control divide. And then you can type your 3/4 x squared. Y'all good typing that in? Okay. And then Control T. Now, how do I know that 0, 0 really is my vertex? Y'all remember what happens in the table? The y values mirror each other, right? They repeat around that y value vertex. Okay, so that's a way to self-check whenever you're identifying. Now, this -1, -0.75, am I going to use that? No. I'm going to skip and only do whole numbers in my table. So I'm going to skip to -2, -3. And then I'm going to skip to -4, -12. Then I'm going to go in the opposite direction. +2, -3. And +4, -12. Y'all good with that? Okay. So then, if I'm looking at my next example, y equals 1/2 times x minus 4 squared, what's going to be my vertex here? 4, 0. Because it's the opposite of your x. So I'm going to dock B. Go back to my graph, and I'm going to type in my 1/2, so control divide. 1/2 x minus 4 squared. Press the wrong button, but and then control T. And I'm going to verify in my table, is 4, 0 my vertex? Yes, because the y values repeat around that y value of the vertex. Alright, am I going to use 3.5? Nope. I'm going to skip to 2, 2. And 0, 8. And then I'm going to go in the opposite direction, 6, 2. And 8, 8. Y'all good with that? Okay, so graphing. Now we're going to put everything together. We're going to graph it. We're going to identify all of our characteristics and all the things. Okay, so my first step is really different kind of, I don't follow this per se. I identify my vertex, I do my table, I graph it, and then I answer the rest. Okay, to me, that's what works more smoothly. You do it whatever order you want to do it, okay? I'm not going to know how you start it, how you end it. This is just how I like to do it, okay? So if I have y equals x minus 1 squared minus 5, what's my vertex? 1, -5. So that's going to be in the middle of my table. So then I'm going to go to my calculator. And I'm going to type my equation. Control T. Is 1, -5 my correct vertex? Yes. Alright. Do I need to skip values? No. So I'm going to copy down 0, -4. And -1, -1, 2, -4, and 3, -1. So the only thing you need this calculator for is your table. Could you build the table without the Inspire? Yes. We've done that before with our absolute value. Okay. I'm going to graph these points. And once I'm done graphing my parabola, I know I have to graph my axis of symmetry. I know it goes through the vertex. I'm going to go ahead and do that. And then I'll be done completely with that graph. But now we're going to answer and identify what is the equation for my axis of symmetry. X equals 1. If you don't put x equals, yes, you will lose credit for that part because it is an equation, because it is a line. Okay, do I have a max or a min? I have a minimum because that vertex is the lowest point. So I have a minimum. If y'all want to just circle it, I'm fine with that. But you're going to have to tell me where it's at. Okay, so it's at y equals where? -5. Okay, my domain, what is that? Okay, up to you, all real numbers, up to you with how you want to write it. I don't remember if I changed my answer key or not. My answer key might only have interval, but it's up to you with what you want to do. Okay, now my range, I have a minimum, so what's my range going to look like? -5 to positive infinity. Or if you do set builder, what's my inequality? Y is greater than or equal to -5. You do not have to put both. Just choose one and stick with it. Okay? Now my transformations. Do I have a reflection? No, I don't have a negative. It opens up, so I don't have a reflection. Do I have a stretch or a shrink? No, I don't have a number in front of my parentheses, so no stretch or shrink. What does this tell me? It shifts right 1 unit. And where else? Down 5 units. Remember that if you get messed up and this throws you off with it being the opposite, you can always look at your vertex. If this is a positive for my vertex, then I went right. You can also look at your graph. Going from the origin, where'd you go? I went right and down. So there's multiple ways to figure that out. I just like to go from my equation. And that's all there is to it. Okay? So let's look at example 4. What's my vertex going to be here? -2, 5. Now, I've got a fraction here, so what is that going to tell me most likely? I'm going to have to, it's a shrink, but what do I know about my table? I'm probably going to have to do what? Skip. So I'm going to scroll in my table to -2, 5. -3 and -1 both give me the same y value, but they are decimals. So I'm going to skip those. And I'm going to have -4, 4. And -6, 1. Then I'm going to have 0, 4. And 2, 1. Are y'all good? Okay. If you mess up on your parabola, that's okay, because I just did. So just make it the best you can. Do not forget to draw your axis of symmetry. I will count off if that's not on your graph. And it better have lines, like dashed lines with arrows. What's the equation for my axis of symmetry? X equals -2. Do I have a max or a min this time? I have a max at, very good. What's my domain? Or okay, my range. If I'm going bottom to top, okay, bottom to top, I have a top boundary now because that's my maximum. So I'm going to end at 5. So if I were doing an interval, what would it be? Very good. Or if I was doing set builder, what's my inequality? Okay, now my transformations. I'm going to go to my equation left to right. What's this negative tell me? Y'all can just tell me reflection this time. I mean, y'all, I know that absolute value we did reflects over the x-axis. Just tell me reflection and I'll be happy. Okay. That 1/4 tells me it's a vertical shrink. Now my key has by a factor of. You're going to do that in pre-calc, all right? We're going to go ahead and just implement it, okay? We didn't do it with absolute value, but we're going to do it here. All you're doing is telling me by a factor of whatever that value is. So by a factor of 1/4. It's not a hard thing to add into your transformations, but might as well learn it now because you're going to do it next year. Okay? So we got reflection, we got vertical shrink by a factor of 1/4. Now what does this +2 tell me? It shifts left 2 units and up 5 units. Okay, last example. What's my vertex going to be? -1, -3. Go to your calculator, doc B, and then type in -2 x plus 1 squared minus 3. Control T. So then to build my table, I'm going to use -2, -5, -3, -11, 0, -5, and 1, -11. Once you plot those points and draw your parabola, draw your axis of symmetry. What's my equation for the axis of symmetry? X equals -1. Do I have a max or a min? At? My domain stays the same no matter what. Who's all doing interval notation? The rest of y'all are doing set builder? Okay. Alright, what's my range going to be? Okay, if you're doing set builder, what am I writing? Very good. All right, my transformations. What do I have? Perfect. Y'all good? Okay, any questions? All right, so for y'all's worksheet, if I were you, I would go through and copy my tables down for everything and then go back and graph and answer everything. Because you've got access to your Inspire now, take advantage of that and just do table, 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 table for all the problems and then go back. Everything else you can do without the calculator. Okay?